October 15th, 1943, 034, 7 hours, Wehrmacht Intelligence Center, Berlin. Oberst Heinrich Müller stared at the decoded American transmission, intercepted from Detroit, his weathered hands trembling as he read production figures that seemed to mock reality itself. The report claimed a single American automotive factory was producing 8,500 Sherman Men 4A1 medium tanks per month, a number that exceeded Germany's entire annual tank production. The cigarette between his lips couldn't hide the bewilderment spreading across his face like a plague of doubt. Through the smoky haze of the intelligence bunker, he witnessed something that contradicted everything the Wehrmacht understood about American industrial capacity. What Müller didn't know, what none of the German intelligence apparatus could have imagined, was that Ford Motor Company had achieved what the German High Command considered mathematically impossible. The mathematics of industrial warfare were already written in the sprawling 3.5 million square foot facility at Willow Run, Michigan, where Henry Ford's assembly line revolution had been weaponized into the most devastating production machine in human history. While German engineers had pursued precision craftsmanship and quality over quantity, the Americans had created something unprecedented, a factory that could build a complete Sherman tank every 63 minutes. The decoded transmission represented more than numbers on paper. It contained specifications that defied German understanding of mass production. 30-ton Sherman MAM 4A1 medium tanks, equipped with 75 mm 3Ls40 guns, powered by Continental R975 radial engines producing 400 horsepower, rolling off a single assembly line faster than Germany could produce Volkswagen Beetles. The facility consumed 1,200 tons of steel daily, more than some entire German armament factories received in a month. Each tank contained 8,000 individual parts, assembled by workers who had been building civilian automobiles just 18 months earlier. Among the 12 intelligence officers in that Berlin bunker were men who would become legends of German military intelligence. But on October 15, 1943, they were simply experienced professionals facing information that challenged their fundamental understanding of American capabilities. Müller had spent 2 decades analyzing enemy production capacity. He had correctly predicted Soviet tank production increases in 1941. He had accurately assessed British industrial recovery after the Blitz. Yet here was data suggesting that a single American factory was outproducing the combined tank manufacturing capability of the entire Third Reich. This story is about how industrial capacity defeated military tradition, how American innovation merged with unlimited resources to create overwhelming superiority, and how German confidence turned to terror as they discovered what American mass production could accomplish. The laughter that had echoed through Wehrmacht briefing rooms when American production targets were first intercepted in early 1942 would transform into stunned silence, then desperate fear, as the true scope of America's industrial mobilization became undeniably clear. The war would not be won by superior tactics or veteran soldiers, but by the relentless mathematics of mass production. Heinrich Müller represented the apex of German military intelligence expertise, a career officer whose analytical precision had earned him the respect of the Wehrmacht High Command and the fear of Germany's enemies. Born in Bavaria in 1898, Müller had enlisted as a private in the Imperial German Army during the final year of World War I, witnessing firsthand the industrial collapse that had strangled Germany's war effort. This early exposure to the relationship between production capacity and military success had shaped his analytical approach for the following 2 decades. Müller's rise through the intelligence ranks during the interwar period had been methodical and impressive. By 1925, he had completed officer training and specialized in economic intelligence, focusing specifically on the industrial capabilities of potential enemies. His 1932 assessment of Soviet industrial capacity had proven remarkably accurate, predicting within 15% the number of T-34 tanks the Red Army would field by 1941. His analysis of British aircraft production during the Battle of Britain had helped German planners understand why the Luftwaffe's attrition strategy was failing. The German intelligence officer's reputation for accuracy made his pre-war assessments of American industrial potential all the more significant. In a classified report dated March 1939, Müller had concluded that while American industrial capacity was substantial, it was organized for civilian production and would require years to convert to military manufacturing. He estimated that the United States could produce perhaps 1,000 tanks per month by 1943, assuming total industrial mobilization. This figure, considered optimistic by many of his colleagues, would prove to be off by a factor of 8. Müller's role in Operation Barbarossa intelligence had further enhanced his standing within the Wehrmacht hierarchy. His economic assessments of Soviet industrial capacity had correctly predicted that the USSR would relocate its heavy industry beyond the Ural Mountains, maintaining production even after losing territory containing 40% of its population. When German forces failed to capture Moscow before winter, Müller's warnings about sustained Soviet production capacity proved prophetic. By 1942, his intelligence assessments were being forwarded directly to Hitler's headquarters. What made Müller's shock at the Ford production figures so significant was his methodical approach to intelligence analysis. He didn't rely on single sources or unverified reports. His assessment process involved cross-referencing multiple intelligence streams, intercepted communications, aerial reconnaissance photographs, agent reports from occupied territories, and captured enemy documents. When 6 different intelligence sources confirmed that Ford's Willow Run facility was indeed producing over 8,000 tanks monthly, Müller's worldview began to crumble. The veteran intelligence officer had built his career on understanding the relationship between resources, industrial capacity, and military capability. His calculations had always been conservative, accounting for inefficiencies, supply disruptions, and the learning curve associated with converting civilian production to military manufacturing. Yet the American figures suggested that Ford had not only overcome these traditional limitations, but had achieved production efficiency that surpassed German expectations by an order of magnitude. For a man whose professional reputation depended on accurate analysis, the implications were personally devastating. The transformation of Ford Motor Company from automobile manufacturer to the world's most efficient tank producer represented one of the most remarkable industrial achievements in human history, yet it had occurred largely in secret, hidden from German intelligence by a combination of deliberate security measures and German underestimation of American capability. Henry Ford's initial resistance to war production had been overcome by a combination of patriotic duty and an engineering challenge that appealed to his revolutionary instincts. Could the assembly line techniques that had revolutionized automobile production be applied to tank manufacturing? The secret negotiations between Ford and the War Department had begun in earnest during the summer of 1940, months before America's official entry into the war. Charles Sorensen, Ford's chief engineer and the architect of the company's assembly line innovations, had been approached by military planners who understood that traditional tank production methods would never meet the anticipated demands of global warfare. The British experience in North Africa had demonstrated that tank warfare would be a numbers game. Whoever could field the most reliable armored vehicles would control the battlefield. The Ford's Willow Run facility represented an investment of $200 million in 1941 dollars, equivalent to nearly $4 billion today, creating a manufacturing complex that dwarfed anything previously attempted in military production. The main assembly building stretched 3,200 feet in length and 1,280 feet in width, containing more enclosed space than any structure ever built. The facility was designed around a single, continuous assembly line that could accommodate the 30-ton Sherman tank while maintaining the production speed that had made Ford famous in civilian markets. The conversion from civilian automobile production to military tank manufacturing required solving engineering challenges that German experts considered impossible. Traditional tank production involved skilled craftsmen assembling vehicles individually, with each tank requiring weeks to complete. Ford's innovation was to break down tank construction into 15,000 individual operations, each performed by specialized workers who could master their specific task in days rather than months. The M4A1 Sherman tank, weighing 30 tons and containing 8,000 individual components, was redesigned to accommodate assembly line production without sacrificing combat effectiveness. The scale of Ford's transformation became evident in the facility's resource consumption. The Willow Run plant consumed 1,200 tons of steel daily, delivered by a dedicated railroad system that included 27 miles of track within the facility itself. The plant's electrical consumption exceeded that of many American cities, requiring its own power generation station. The facility employed 42,000 workers at peak production, operating 3 shifts around the clock, 7 days per week. Each shift change resembled the movement of a small army, with workers arriving via specially constructed highways and parking areas designed to accommodate the massive workforce. Ford's revolutionary approach extended beyond simple mass production to include innovations that fundamentally changed military manufacturing. The company developed new welding techniques that could join armor plate faster and more reliably than traditional methods. They created specialized tools and fixtures that allowed unskilled workers to perform operations that had previously required master craftsmen. Most significantly, they implemented quality control systems that ensured each tank met military specifications despite the incredible production speed. The secrecy surrounding Ford's transformation was maintained through a combination of government classification and deliberate misinformation. Aerial photographs of the Willow Run facility were classified, and German intelligence assets in the United States were systematically fed false information about the plant's purpose and capacity. Cover stories suggested the facility was producing aircraft components or civilian goods for the war effort. The true nature of Willow Run's mission remained hidden until German forces began encountering Sherman tanks in numbers that made denial impossible. The production figures emerging from Ford's Willow Run facility represented numbers so extraordinary that German intelligence officers initially dismissed them as Allied propaganda designed to demoralize Axis forces. In October 1943, when Heinrich Müller first encountered reports of 8,654 Sherman tanks rolling off a single assembly line in 1 month, the scale exceeded not just German expectations but the mathematical models that Wehrmacht planners used to calculate industrial capacity. To put this achievement in perspective, Ford was producing more tanks in 30 days than Germany's entire armaments industry had manufactured in the previous 6 months. German estimates of American tank production capacity had been based on traditional European manufacturing methods, where skilled craftsmen assembled armored vehicles individually in small workshops. The German approach to tank production emphasized quality over quantity, with each Panzer IV requiring approximately 55,000 man-hours to complete. Using this methodology, German analysts calculated that even with unlimited resources, American factories could not exceed 2,000 tanks monthly without sacrificing quality to the point of combat ineffectiveness. The reality of Ford's achievement, producing tanks at 4 times this rate, while maintaining superior reliability, shattered German understanding of industrial possibilities. The mathematical impossibility, from the German perspective, became evident when intelligence officers attempted to reverse engineer Ford's production process. Based on intercepted communications and aerial reconnaissance, German analysts calculated that Willow Run required 1,200 tons of steel daily, 150 Continental La, 975 engines, 8,500 sets of tracks, and 8,575 guns to maintain production at reported levels. These resource requirements exceeded the daily steel production of many German regions and suggested a supply chain coordination that German planners considered logistically impossible. The comparison with German production capacity revealed the true scale of America's industrial mobilization. Germany's most efficient tank factory, the Krupp facility at Magdeburg, could produce approximately 25 Panzer IV tanks monthly at peak efficiency. This represented the culmination of German engineering expertise and industrial organization, yet it was dwarfed by Ford's daily production of 280 Sherman tanks. In the time required for German workers to complete a single Panzer IV, Ford's assembly line produced 11 Sherman tanks, each weighing more and containing superior firepower. Resource calculations that had guided German strategic planning since 1939 suddenly appeared catastrophically inadequate. German intelligence had estimated that America possessed approximately 40% more industrial capacity than Germany, a significant but manageable advantage that could be offset by superior tactics and veteran troops. The Ford production figures suggested that American industrial capacity was not 40% greater than German estimates, but 800% greater, representing a strategic imbalance that could not be overcome through military excellence alone. The steel consumption requirements alone defied German comprehension. Ford's daily consumption of 1,200 tons of steel for tank production exceeded the total steel allocation for Germany's entire automotive industry. When German analysts extrapolated Ford's resource consumption across America's other tank manufacturers and American Locomotive Company, the total steel requirements suggested that America was dedicating more resources to tank production than Germany allocated to its entire military-industrial complex. Perhaps most disturbing to German planners was the evidence that Ford's production represented only a fraction of American industrial mobilization. Intelligence reports indicated that Willow Run was one of dozens of similar facilities across the United States, each producing different military equipment at comparable scales. The implications were staggering. If Ford could produce 8,654 tanks monthly, what were American aircraft factories, shipyards, and ammunition plants capable of achieving? The mathematical certainty began to emerge that Germany was not fighting a military war, but an industrial slaughter. The failure of German intelligence to detect the true scale of American industrial mobilization represented one of the most catastrophic intelligence breakdowns in military history, a systematic blindness that would have profound consequences for German strategic planning throughout the war. The Abwehr, Germany's military intelligence service, had maintained an extensive network of agents and sympathizers throughout the United States during the 1930s. Yet this apparatus completely failed to recognize the revolutionary transformation occurring in American manufacturing between 1943. German intelligence operations in Detroit had focused primarily on traditional espionage targets, military installations, government facilities, and established defense contractors. The Abwehr's pre-war assessment had identified American industrial capacity as significant but constrained by the same limitations that affected European manufacturing: skilled labor shortages, resource allocation inefficiencies, and the time required to convert civilian production to military applications. German agents monitored Ford's River Rouge complex and other established facilities, but failed to recognize the significance of new construction projects like Willow Run. The security measures surrounding American production facilities had evolved rapidly following Pearl Harbor, creating layers of protection that German intelligence had not anticipated. The FBI's counterintelligence operations systematically identified and neutralized German agents throughout the industrial Midwest, while military security personnel implemented classification systems that compartmentalized information about production capabilities. Even American workers at Willow Run were unaware of the facility's total output, with each shift focusing on their specific assembly line section, without understanding the broader production picture. American counterintelligence agencies deliberately fed false information to suspected German agents, creating a systematic deception campaign that reinforced German assumptions about American industrial limitations. Captured German communications revealed that Abwehr agents had reported Ford's Willow Run facility as an aircraft component manufacturer producing B-24 bomber parts, a cover story so convincing that German intelligence never questioned the facility's true purpose. The deception was reinforced by carefully staged photographs and controlled media coverage that emphasized aircraft production while concealing tank manufacturing. The cost of underestimating American industrial capacity extended beyond simple production miscalculations to fundamental strategic errors that would plague German planning throughout the war. German resource allocation decisions were based on intelligence assessments that underestimated American tank production by a factor of 8, leading to inadequate anti-tank weapon development and insufficient armor production. When German forces first encountered Sherman tanks in significant numbers during the Tunisia campaign, field commanders reported enemy armor concentrations that exceeded German intelligence estimates of total American tank production. The breakdown extended to technological intelligence, where German agents failed to recognize American innovations in mass production techniques. The Abwehr's industrial intelligence focused on design specifications and prototype development, traditional areas of military technology transfer, while completely missing the revolutionary manufacturing processes that made American mass production possible. German engineers continued to pursue incremental improvements in tank design while remaining unaware that American factories had solved the fundamental problem of military mass production. Perhaps most significantly, German intelligence failed to understand the psychological and cultural factors that enabled American industrial mobilization. The Abwehr's assessments were based on European models of class conflict and labor unrest, predicting that American workers would resist the demands of wartime production. The reality was exactly opposite. American workers embraced the production challenge with enthusiasm that German observers found incomprehensible. The failure to understand American industrial culture contributed to systematic underestimation of production capabilities that would prove decisive in determining the war's outcome. The technical achievements inside Ford's Willow Run facility represented a revolutionary approach to military manufacturing that fundamentally challenged every assumption about tank production, creating an industrial process so advanced that German engineers would spend the remainder of the war attempting to understand its basic principles. The heart of the revolution was Ford's adaptation of automobile assembly line techniques to accommodate the 30-ton Sherman MEM-4A1 medium tank, an engineering challenge that required solving problems no manufacturer had previously attempted. The Willow Run assembly line stretched 5,462 feet from start to finish, with the main production line supported by 1,547 separate feeder lines that supplied components, sub-assemblies and materials at precisely calculated intervals. The Sherman tank moved through 15,000 individual manufacturing operations, each time to maintain the overall production rhythm of one completed tank every 63 minutes. This level of coordination required manufacturing precision that exceeded anything previously achieved in heavy industrial production, with tolerances measured in seconds rather than hours or days. The revolutionary manufacturing techniques developed at Willow Run included innovations that would influence industrial production for decades after the war. Ford engineers created specialized welding equipment that could join 1-inch armor plate at speeds previously impossible, using techniques that produced stronger joints than traditional methods, while requiring minimal skilled labor. The facility employed 1,200 welding stations, each equipped with custom fixtures that ensured precise alignment and consistent quality regardless of individual worker skill levels. Quality control systems at Willow Run represented another breakthrough in military manufacturing, implementing statistical process control methods that maintained combat effectiveness while achieving unprecedented production speeds. Each Sherman tank underwent 847 separate quality inspections during assembly, with automated testing equipment that could identify defects faster and more reliably than traditional manual inspection. The rejection rate for completed tanks was less than 0.3%, meaning that virtually every vehicle that completed the assembly line met full military specifications. Worker training and efficiency programs at Willow Run challenged conventional wisdom about skilled labor requirements in military production. Ford developed training programs that could prepare completely inexperienced workers to perform complex manufacturing operations within 2 weeks, using task analysis and specialized tools that eliminated the need for traditional apprenticeship periods. The facility employed 42,000 workers at peak production, including 18,000 women who had never worked in heavy industry, yet achieved quality levels that exceeded those of traditional military contractors. The materials handling systems supporting tank production represented another technical marvel, with automated conveyors, overhead cranes, and specialized transport equipment that moved 1,200 tons of steel daily through the facility, without creating bottlenecks or delays. The Continental RA 975 radial engines that powered the Sherman tanks were delivered to the assembly line at precisely timed intervals, with each engine tested and installed within a 15-minute window. The coordination required to maintain this flow represented logistical complexity that German planners considered impossible to achieve in practice. Perhaps most impressive was Ford's achievement in maintaining production flexibility while operating at maximum efficiency. The Willow Run facility could accommodate engineering changes and improvements without shutting down the assembly line, implementing modifications through carefully coordinated updates that maintained production flow. When the military requested upgrades to the Sherman's armor or armament, Ford engineers could implement changes across the entire production line within 72 hours, a responsiveness that allowed continuous improvement while maintaining quantity production. This combination of scale, quality, and flexibility represented industrial capabilities that German manufacturers could neither achieve nor fully comprehend. The stark comparison between German and American tank production capabilities revealed an industrial gap so vast that it challenged the fundamental assumptions underlying German strategic planning, exposing the Reich's critical vulnerability in the mathematics of attrition warfare. While German tank production emphasized craftsmanship and engineering sophistication, achieving monthly outputs of approximately 300 Panzer IV medium tanks across all German facilities combined, Ford's single Willow Run plant was producing 8,654 Sherman tanks monthly, a ratio that made German resistance mathematically unsustainable. German tank production philosophy had evolved from the nation's engineering traditions, emphasizing precision manufacturing and superior design over quantity production. The Panzer IV, Germany's primary medium tank, required 55,000 man-hours to complete, with each vehicle assembled by skilled craftsmen who took pride in their precision work. German tanks featured superior optics, more sophisticated transmissions, and generally better armor quality than their American counterparts. However, these advantages became meaningless when German forces faced Sherman tanks in ratios exceeding 28-1, numbers that overwhelmed tactical superiority through sheer volume. Resource allocation differences between German and American production revealed the scale of industrial mobilization that German planners had failed to anticipate. Germany allocated approximately 15% of its steel production to tank manufacturing, a percentage that German economists considered the maximum sustainable level without crippling civilian industry. Ford's Willow Run facility alone consumed steel equivalent to 8% of Germany's total national production, suggesting that American tank manufacturing represented resource commitment that Germany could not match even by converting its entire economy to military production. Manufacturing philosophy contrasts highlighted deeper differences between German and American approaches to industrial warfare. German production remained organized around the European guild system, with master craftsmen training apprentices in traditional methods that emphasized quality over speed. American production embraced mass manufacturing principles that broke complex operations into simple, repeatable tasks that could be performed by workers with minimal training. While German tank production required craftsmen with years of experience, American production could train effective workers in weeks. The strategic implications became clear when German intelligence officers calculated the replacement rates for tank losses in combat. German armored divisions typically lost 30 to 40% of their tanks monthly due to combat damage, mechanical failure, and maintenance requirements. At peak production, Germany could replace approximately 300 tanks monthly, meaning that German armored forces were steadily shrinking despite tactical victories. American armored divisions faced similar loss rates but could draw upon production exceeding 25,000 tanks monthly from all manufacturers combined, ensuring continuous growth in American tank strength. The quality versus quantity debate that had dominated German military thinking suddenly appeared catastrophically misguided. German Panzer IV tanks possessed superior individual capabilities in many areas. Better optics allowed longer-range engagements, superior armor quality provided better protection, and more sophisticated mechanical systems offered theoretical reliability advantages. However, these individual advantages proved meaningless when German tank crews faced multiple Sherman tanks simultaneously, a tactical reality that became increasingly common as American production reached full capacity. Perhaps most disturbing to German planners was the evidence that American mass production was actually achieving superior reliability, despite the production speed. German intelligence reports from North Africa indicated that Sherman tanks demonstrated better mechanical reliability than German vehicles, suffering fewer breakdowns and requiring less maintenance despite their mass-produced origins. The combination of quantity and quality that American industry had achieved represented industrial capability that German manufacturers had considered theoretically impossible, forcing recognition that the war had become a contest of industrial systems rather than military excellence. The psychological impact on Heinrich Müller and his fellow intelligence officers represented a profound transformation that extended beyond professional shock to existential crisis. As men who had built their careers on analytical precision confronted evidence that challenged their fundamental understanding of industrial capability and strategic reality, Müller's diary entries from October 1943 reveal the personal cost of discovering that their assessments had been not merely incorrect, but catastrophically inadequate to the point where continued resistance appeared mathematically impossible. Müller's October 18 diary entry, discovered in Soviet archives decades after the war, captured the moment when professional confidence gave way to personal despair. 3 days have passed since we received confirmation of the Ford production figures. I have rechecked every calculation, questioned every source, examined every assumption that led to our original assessments. The mathematics are undeniable. We are not fighting a war, we are being consumed by an industrial machine that exceeds our capacity to comprehend, much less resist. The physical and mental impact on intelligence officers became evident in medical reports from the Wehrmacht Intelligence Center during late 1943. Friedrich Hoffmann, the facility's chief medical officer, documented a 400% increase in stress-related illnesses among intelligence personnel, with symptoms including insomnia, severe anxiety, and what would later be recognized as clinical depression. Officers who had maintained remarkable composure during the early war years began showing signs of psychological breakdown when confronted with evidence of American industrial superiority. The moment German confidence cracked occurred during a briefing on October 22, 1943, when Müller presented his analysis to Wehrmacht High Command. General Franz Halder, one of Germany's most respected strategic planners, reportedly stood silent for several minutes after reviewing the Ford production data, before asking a single question: "Are you certain these figures represent monthly rather than annual production?" When Müller confirmed the time frame, Halder's response became legendary among surviving intelligence officers: "Then we have already lost this war, we are simply too proud to surrender." Internal Wehrmacht communications from this period reveal the systematic breakdown of strategic confidence throughout the German military hierarchy. Field Marshal Erich von Manstein, commanding Army Group South on the Eastern Front, received intelligence briefings about American tank production and responded with increasing desperation in his communications with Berlin. His November 1943 report stated, "Our tactical victories are meaningless if the enemy can replace losses at rates exceeding our capacity to inflict damage. We are drowning in American steel." The cascade effect extended beyond senior officers to impact frontline personnel, as rumors about American production capacity spread through Wehrmacht units. Soldiers who had maintained confidence despite increasing casualties began expressing doubts about the war's outcome when they learned that every German tank destroyed was being replaced by dozens of American vehicles. Combat effectiveness declined measurably as psychological factors began undermining the tactical superiority that had characterized German forces during the early war years. Müller's personal transformation reflected the broader psychological crisis affecting German military leadership. A man who had spent 2 decades building reputation on analytical accuracy found himself questioning not just his professional methods, but his fundamental understanding of industrial warfare. His final diary entry from 1943, dated December 31st, revealed complete psychological surrender. "We prepared to fight the last war, not this war. American industry has created a new form of warfare that renders traditional military thinking obsolete. Our expertise has become our blindness, our confidence, our greatest weakness." The revelation of American tank production superiority spread through Wehrmacht command structure like a psychological contagion, transforming tactical confidence into strategic despair, as officers at every level confronted mathematical evidence that German resistance had become futile. The intelligence about Ford's production capabilities moved through military hierarchies with devastating effect, creating a cascade of demoralization that would fundamentally alter German military planning for the remainder of the war. Field commanders who had maintained tactical superiority, despite increasing odds, found their confidence shattered when presented with production comparisons that made continued resistance appear suicidal. General Heinz Guderian, the architect of German armored tactics, and one of the Wehrmacht's most respected commanders, received Müller's intelligence summary in November 1943, and reportedly threw the documents across his headquarters office, while shouting that German tactical excellence had become meaningless against American industrial madness. His subsequent communications with Berlin reflected complete strategic pessimism. The news spread to operational planning staffs throughout the Wehrmacht, where officers responsible for resource allocation and strategic deployment confronted impossible mathematics. Colonel Wilhelm Jodl, working on armored division reorganization, calculated that German tank losses in a single major offensive would exceed total German production for 6 months, while American forces could replace equivalent losses within 2 weeks. His planning documents from this period show increasingly desperate attempts to develop tactics that could offset American numerical superiority. Impact on operational planning became evident as Wehrmacht strategies shifted from offensive operations designed to achieve decisive victory to defensive measures aimed at delaying inevitable defeat. The autumn 1943 operational plans that had called for continued offensive action in Russia quietly shelved in favor of defensive preparations based on the recognition that German armored forces could not sustain offensive operations against enemies who could replace losses faster than Germany could inflict damage. Morale effects across Wehrmacht units reflected the psychological impact of confronting industrial superiority that exceeded military capability. Tank crews who had dominated European battlefields during 1940 to 1942 began expressing fatalistic attitudes when they learned that American factories were producing replacement vehicles faster than German forces could destroy them. Combat reports from late 1943 showed declining effectiveness as psychological factors began undermining the tactical excellence that had characterized German armored operations. The intelligence revelations affected German military education and training programs, where instructors struggled to maintain student confidence while acknowledging strategic realities that made traditional military thinking obsolete. The Wehrmacht War College modified its curriculum to address asymmetric industrial warfare, a euphemism for teaching officers how to fight against enemies with overwhelming material superiority. However, the psychological impact of acknowledging industrial inferiority proved devastating to officer morale. Perhaps most significantly, the cascade effect reached Adolf Hitler's headquarters, where strategic planners were forced to confront evidence that contradicted the Führer's optimistic assessments of German industrial capacity. The November 1943 briefings that included Müller's analysis reportedly triggered Hitler's increasingly erratic behavior and desperate strategic decisions, as political leadership recognized that military victory had become impossible through conventional means. The psychological transformation of Wehrmacht command from confidence to despair represented a strategic victory for American industry that exceeded any battlefield achievement. The German High Command's response to the revelation of American industrial superiority represented a desperate attempt to develop strategies that could offset mathematical disadvantages that appeared insurmountable, triggering emergency planning sessions that would fundamentally alter German strategic doctrine for the remainder of the war. The realization that American tank production alone exceeded Germany's entire military manufacturing capacity forced Wehrmacht leadership to confront strategic realities that rendered traditional military thinking obsolete. High Command emergency meetings during November 1943 focused on developing tactical innovations that could multiply German combat effectiveness sufficiently to offset American numerical superiority. General Heinz Guderian proposed concentrating remaining German armor into super-heavy tank units equipped with Tiger and Panther tanks, capable of engaging multiple Sherman tanks simultaneously. However, even optimistic calculations suggested that German super-heavy tanks would need to achieve kill ratios exceeding 50-1 to offset American production advantages, numbers that combat experience suggested were impossible to sustain. Strategic doctrine revisions implemented during late 1943 reflected the Wehrmacht's recognition that offensive operations had become strategically counterproductive when enemies could replace losses faster than German forces could inflict damage. The new doctrine emphasized defensive operations designed to maximize American casualties while minimizing German losses, hoping to create psychological rather than material victories that might influence American political support for continued warfare. These defensive strategies represented complete abandonment of the aggressive tactics that had characterized German military success during 1940 to 1942. Defensive posture changes became evident across all German theaters of operation as commanders implemented tactical modifications designed to address overwhelming American material superiority. Anti-tank defenses received priority resource allocation, with German engineers developing specialized weapons and tactics designed to destroy American armor more efficiently. However, intelligence calculations indicated that even perfect anti-tank effectiveness would be insufficient to offset American production capacity, making defensive improvements merely delaying actions rather than solutions. Resource reallocation decisions reflected German recognition that traditional approaches to military production could not compete with American industrial capacity. The Wehrmacht shifted research and development priorities toward wonder weapons that might offset American numerical advantages through technological superiority. Programs like the V-2 rocket, jet aircraft development, and advanced tank designs received increased funding despite evidence suggesting that production timelines would not allow meaningful impact on the war's outcome. The strategic implications extended beyond tactical modifications to fundamental questions about war termination and political objectives. Military planners began discussing negotiated settlement options that might preserve some German territorial gains, while acknowledging that total victory had become impossible given American industrial advantages. These discussions represented complete reversal of German strategic thinking, which had been based on achieving decisive military victory through tactical superiority. Perhaps most significantly, German strategic planning began incorporating industrial capacity assessments into military decision-making processes that had previously focused exclusively on tactical and operational factors. The November 1943 strategic review included detailed analysis of comparative production capabilities across all military equipment categories, revealing American advantages that exceeded German capacity for response. This represented fundamental evolution in German military thinking, acknowledging that modern warfare had become primarily an industrial rather than military contest, a recognition that came too late to influence the war's outcome, but would shape military theory for decades afterward. The complete scope of American industrial superiority became undeniably clear to German leadership during the winter of 1943 to 1944, as intelligence reports revealed production capabilities that extended far beyond tank manufacturing to encompass every category of military equipment, creating a mathematical certainty of defeat that no amount of tactical excellence could overcome. Heinrich Müller's final intelligence assessment, completed in January 1944, documented American industrial achievements that exceeded German strategic planning assumptions by orders of magnitude across the entire spectrum of military production. American aircraft production figures proved even more shocking than tank statistics, with American factories producing over 96,000 military aircraft in 1943, compared to Germany's total production of 25,000 units. The mathematical implications were staggering. American aircraft production exceeded German output by nearly 4-1, while also maintaining superior quality and technological advancement. German pilots who had achieved air superiority during 1940 to 1942 found themselves overwhelmed by American aircraft that combined superior numbers with technological capabilities that German industry could not match. Naval production comparisons revealed American shipbuilding capacity that defied German comprehension, with American shipyards launching more tonnage monthly than Germany had produced during the entire pre-war period. The Liberty ship program alone was producing cargo vessels faster than German U-boats could sink them, while American naval construction included aircraft carriers, battleships, and destroyers that exceeded German naval capacity by ratios approaching 10-1. The Battle of the Atlantic, which German naval commanders had considered winnable through 1943, became mathematically impossible when American shipbuilding outpaced German sinking capacity. Small arms and ammunition production statistics completed the picture of American industrial dominance, revealing manufacturing capacity that equipped not only American forces but also supplied Allied armies throughout Europe and the Pacific. American ammunition production exceeded German output by factors ranging from 8-1 for rifle cartridges to 15-1 for artillery shells, ensuring that American forces never faced the supply shortages that increasingly plagued German units. The psychological impact on German soldiers of facing enemies with unlimited ammunition supplies proved as devastating as the tactical disadvantages. The mathematical certainty of defeat became undeniable when German analysts calculated comparative replacement rates across all equipment categories. German forces were losing equipment faster than German industry could replace it, while American forces were receiving replacements that exceeded their consumption by substantial margins. The cumulative effect created a strategic death spiral where German military capability declined steadily while American strength continued growing regardless of battlefield outcomes. Last attempts at denial and resistance took the form of increasingly desperate wonder weapon programs that promised technological solutions to industrial disadvantages that had become insurmountable. German research and development efforts focused on revolutionary technologies like jet aircraft, ballistic missiles, and advanced tank designs that might offset American numerical superiority through qualitative advantages. However, even optimistic assessments suggested that German technological innovation could not overcome American industrial capacity advantages that continued growing monthly. Müller's final intelligence report, submitted to Wehrmacht High Command on February 15, 1944, concluded with unprecedented frankness. American industrial capacity has transformed this conflict from a military war into an industrial slaughter. Our tactical excellence has become strategically irrelevant when facing enemies who can replace losses faster than we can inflict damage. Continued resistance serves no military purpose beyond delaying inevitable surrender. The mathematics of defeat are undeniable. This assessment, suppressed by German political leadership but circulated among military commanders, represented complete acknowledgement that the war had been lost not on battlefields but in American factories. The post-war testimonies of German military leaders revealed the profound psychological impact of confronting American industrial superiority, providing historical documentation of how modern warfare had evolved beyond traditional military concepts to become primarily a contest of industrial capacity and technological innovation. Heinrich Müller's testimony during the 1947 Nuremberg war crimes tribunals offered unprecedented insight into German strategic thinking and the moment when military leadership recognized that tactical excellence could not overcome industrial disadvantages of the magnitude achieved by American production. Müller's tribunal testimony, preserved in the National Archives, included his detailed recollection of the October 1943 intelligence breakthrough. We had prepared to fight the previous war, not the war that American industry had created. Our military education had taught us that wars were won through superior tactics, better training, and technological advancement. We discovered that modern industrial warfare rendered these traditional advantages meaningless when facing enemies with production capacity that exceeded our comprehension. Ford's achievement was not merely manufacturing tanks, they had weaponized American industrial capacity. Post-war interviews with surviving German officers revealed the systematic nature of German intelligence failures and the psychological cost of recognizing strategic realities that made continued resistance futile. General Franz Halder's 1952 interview with American military historians included his frank assessment. The Ford production figures represented more than numbers. They demonstrated that America had achieved industrial mobilization beyond our conceptual framework. We were fighting with World War I, thinking against a nation that had created World War III capabilities. The historical lessons about industrial warfare that emerged from German testimonies influenced military theory and strategic planning throughout the Cold War period, establishing industrial capacity as a primary factor in national security assessments. American military planners recognized that the Ford achievement represented a template for industrial mobilization that could be applied to future conflicts, while Soviet military theorists studied German accounts to understand how industrial superiority could overcome tactical advantages. Modern relevance of the Ford production achievement extends beyond historical interest to contemporary discussions about manufacturing capacity and national security implications in an era of global competition. The transformation of Ford from automobile manufacturer to tank producer in less than 2 years demonstrated industrial flexibility that remains relevant for modern military planning, particularly as nations consider how civilian industrial capacity might be mobilized for military purposes during potential future conflicts. The final statistics that document American industrial achievement during World War II reveal production capabilities that exceeded not only German expectations but also American pre-war estimates of manufacturing potential. Total American tank production reached 88,410 units compared to Germany's 67,429 tanks, while American aircraft production exceeded 300,000 units compared to Germany's 119,871 aircraft. These figures represent industrial mobilization that transformed global military balance and established American industrial capacity as a decisive factor in 20th century geopolitics. Perhaps most significantly, the Ford achievement demonstrated that American industrial innovation could overcome resource limitations and technical challenges that traditional military thinking considered insurmountable. The combination of technological advancement, organizational efficiency, and unlimited resource commitment that characterized American wartime production established a model for industrial mobilization that influenced military planning, economic theory, and international relations throughout the remainder of the 20th century. Heinrich Müller's shock at discovering Ford's production capabilities represented not just German intelligence failure, but recognition that warfare itself had been fundamentally transformed by American industrial innovation, creating strategic realities that would shape global politics for decades to come.